So hello guys, welcome to my channel. Today in this video we'll discuss about today's Leetcode POTD, open the lock. Okay, so my name is Shushil. Let's move towards the problem. So let's read the problem statement here. You have a lock in front of you with 4 circular wheels. Each wheel has 10 slots 0, 1, 2, 3, dot or 9. Okay, the wheel can rotate freely and wrap around. For example, we can turn 9 to be 0 or 0 to be 9. Each move consists of turning one wheel one slot. So the let's we can imagine the wheel is present in this fashion. Okay, the numbers are present in this fashion, and by rotating wheel by one position we can move from 9 to 0 or 0 to 9. Okay, the numbers are connected circularly. So by using some simple observation we can simply derive a formula here, that is 10 plus I, where I is basically the current index where we are standing, and k is basically the number of movements we are doing modulo 10. Okay, we can simply derive this particular formula to find the index that we can reach by moving k position from I. For example, we are standing at 0. If we move plus 2 direction, okay, plus 2 direction, let's uh, take the clockwise direction as positive and the anti-clockwise as negative. Okay, so if we move plus 2, that means 2 steps in clockwise direction, then the value is here, the value of I is 0, the value of k is 2 modulo 10, that will simply equals to 2. Okay, that means we simply return 2. So let's check the validity of that answer. If we move 2 steps from 0, we at first we move one step, we reach 1, then again one step we reach 2. Okay, that means the answer is valid. Let see, we are standing at 2. Okay, that means the value of I is 2, and now I want to move in anti-clockwise direction. So let's denote the anti-clockwise as negative, and I am moving 5 steps in this direction. Okay, 5 steps in this direction from 2. So here will be minus 5 modulo 10. So what will be the value? That is 12 minus 5 modulo 10. 12 minus 5, 7. The answer is basically 7. So let's check the validity. We are moving 5 steps, right? So after moving 1 step we reached 1, then 2 step we reach 0, after 3 step we reach 9, after 4 step we reach 8, and finally we reach 7. So the answer is valid. So we can simply using this formula here. Okay, now what is given here, that the lock initially starts at quadruple 0. A string represents the state of 4 wheels. Okay, the lock initially starting from 4 zeros, that basically representing the initial state of the wheels. Okay, there are 4 different wheels, and you are given a list of dead ends, meaning if the lock displays any of this code, the wheel of the lock will stop turning around and will be you will be unable to open it. That means I have also given a list of dead ends. Okay, that is basically a list of strings that contains some sort of strings which is basically dead ends. That means if anyhow this particular lock reaches this state, then the lock will stop working. That means we cannot move the wheel further. Okay, and we have given a target representing the value of wheels that will unlock the lock. Return the minimum total number of turns required to open the lock, or return -1 if it is impossible. That means we have simply given a target. That is basically a 4 length string. For example, let's take it as 0, 1, 3, something, it can be anything, and we have to return the minimum number of steps to reach from 0, 0, 0 to the target. Okay, and in this path we cannot reach the dead end string. If anyhow we reach any of this string present in the dead end list, then instantly the lock will stop working. Okay, so for example, the target string is 002, and initially the lock is in this particular state, and the dead end list basically consists 2 strings, that is 001 and 0101. So if we simply want to reach this particular state, what we can do that we reach from 0 0 0 to 0 0 0 1, okay, by rotating this particular wheel, and then from this state we simply reach this state by rotating this particular wheel. But as this particular string is present in dead end, so we cannot reach this particular string, okay. We have to uh, derive some another path to reach this particular string. So this problem can be also uh, simulate like trees, okay. We can think this as sort of uh, graphs for saying we can think this problem as of graphs, where the initial state is this, the initial node is this particular string, and its children node is basically the string that can be derived by moving only one wheel, okay. For example, if I move this particular wheel, I can derive these particular strings, then 0 0 9, okay. So all the possible strings that can be derived by moving only one will be its children, okay. For more precisely, we can say there is an edge, there is an edge between two nodes if the both the nodes, okay, both the strings only both the strings only differ only in one position, okay. Both the strings differ only in one position, and only in one position, and any of them is not present in the dead end, okay. This is very important. If any of the string is present in dead end, then is there will be no possible edge, right? So none of them is present in dead end list. So by doing this, we can simply form a graph starting from this particular state, which are connected in this fashion, okay. And there can also be some sort of connections here. So in this fashion we can form a graph, and after forming this we can simply derive the minimum steps to reach from this particular to target by using the to find algorithm to find minimum paths, algorithm to find minimum paths, minimum path in graph, right? We can simply do this by using BFS, okay. This can be done simply by using BFS. We can simply return the minimum distance between the target node and the starting node, that is quadruple 0, right? So let's move towards the code, and then it will be much more clear. So what we are doing here is that at first we are declaring a string s, okay, that is basically quadruple 0, and then we are taking an unordered set of strings in which we will store all the strings that consist in the dead ends, okay. And then there is an edge case, is that if the initial string is present already in the dead ends or not. If the initial string is present in the dead ends, that means uh, this will be true, and in that case we will return -1, because if the initial string is present in the dead ends, then there is no way to reach the target, right? Because initially the lock will reach the dead end and this will stop working, okay. So this is the base case for which we are checking here, that if the initial string is present in the dead end, then we will return -1, okay. Then we declaring a queue here and pushing the initial strings inside the queue. Then we declare a counter variable and pushing the initial string in this set. Here we are basically using this unordered set st to push all the strings of dead ends in the inside set, okay, so that whenever we reach a particular children node, we can check whether it is present in the dead ends or not by using simply st.find or st.count function, okay. So so that here we use set to store all the dead end strings, and also we will use set inside our BFS to store the inside our BFS to store the already visited node. Okay, so this will work as the visiting array we use in BFS traversal. So what we are doing here, let's see step. We initially push the string inside queue, then we declare a counter variable initialized to 0, then we insert the string in set, that is basically the initial string, and then we are doing a BFS traversal here we are taking initially the size of the queue. Okay, and then we are basically simulating all the levels. Okay, all the levels by using this inner loop. Okay, we are taking here basically a loop of n length, and in each loop we are basically popping the element of a particular level. For example, what we are doing here is that we don't take here any sort of 2D vector, right? We are basically taking initially a queue, and what we are doing here is that initially we have pushed this particular string inside our queue. We have pushed this particular string inside our queue, and then what we are doing, we are pushing all these childrens in the queue. Okay, that only differs by one position in the queue. For example, there are k number of children, and popping this, and in the next step we are taking the size of the queue. Okay, that is basically k, size of the queue, and then we are popping this and again pushing its children in the queue. In each step we are basically, what we are doing, we are basically taking the length of the queue as levels. Okay, and after each level we are basically increment our counter variable. Here this is actually done. Let's look carefully. What we are doing, we are basically taking the length of the queue in n. Okay, and then after popping all the elements of the queue by using this loop, then we are incrementing our counter. That means after the loop is, after the entire iteration of the loop, after popping all the corresponding nodes of a level of length k, let's say, then we are moving to the next level. Okay, incrementing the counter cnt, and for that reason we are basically taking the length of the queue, and then inside the queue we are doing operations. We are pushing the corresponding childrens after this particular segment, and then we are basically incrementing the counter here. Okay, if I code this particular segment step by step, it would be much more clear. Let's omit this. So let's code it from scratch. So what we are doing here is that we are basically doing a simple BFS traversal where I am initially taking the length of the queue. This is basically the length, of queue of corresponding level. This is basically the length of queue of corresponding level. Okay, we are taking that particular length, okay, of a particular level. Then we are eventually doing our process in this level, and after this level we are incrementing our counter as our level is incremented one step. Okay, now I think it is clear to you that what we are basically doing. We are basically taking the length of the queue of a particular level. Okay, that is basically the length of a particular level. Let's say this is level 1. We are basically taking this length and doing processes in this particular length that eventually push more elements after this. Okay, and then we are moving to the next level and again taking the length of that particular level. Okay, so in this way we are doing BFS here, and inside each level what we are doing here what I have taken, that I have taken the length of queue of corresponding level. Okay, then I am doing operations in that particular level. So what I will do is that at first I will take the topmost element, that is front element of the queue, queue dot front. Then I am checking whether it is equal to target or not. If it is equal to target, then I will simply return cnt here, and then I am popping the element. Okay, now what I will do, I will store the children of the string temp inside our queue. So how we will do that? We will declare a loop of length 4, I have to declare another variable, as I is already taken in that loop. So I am taking as k, and this is basically iterating through each index of the temp, okay, and moving that particular wheel from one step forward or backward. Okay, so let's take two strings. One is increment, and we will initialize with temp, and let's take another string, that is decrement, and we will also initialize with temp. Okay, I am basically taking increment as incrementing one wheel, and decrement string, what we will do, we will decrement one wheel. Okay, for example, if if the temp string here, if the temp string is this, then if I increment this particular index, then it will be this, right? And I will store this in our increment string, and if I decrement this particular string, this will be 0019. That means moving towards the anti-clockwise direction, I will store it in decrement string. Okay, so that I am doing here basically. And what I will do, I will take the corresponding kth index of the string. Okay, I will take the kth index of the string, that is temp k, and will be subtracting 0, that will eventually return an integer and storing it in k. Then I will do operation a underscore 1. A underscore 1 is basically signifies a after incrementing it, and I will use the formula here, that is 10 plus the current value is a. So here I will write a, then I will incrementing 1, okay, and modulo 10, and in increment string I will modify this. Okay, what I will do, here I will store a underscore 1. So before storing this, I have to typecast it, that is a underscore 1 plus 0. Now I will take another integer a underscore 2, what signifies the value of a after decrementing it by 1, and take modulo of 10. Then I will modify our decrement string, that is dicrk, it is equals to, and then I will typecast a underscore 2 plus 0. Okay, now what we will do, we will simply check whether it is present in this set or not. Okay, whether it is present in the set or not. If it is present in the set, then we cannot push in the queue, because it is either it is either visited previously, or it can be stored in the read. So in that case we will simply ignore. But if it is not present in the string of set, in that case we will simply push this particular string in our queue, and also will marking it as visited by inserting it in our set. So the same thing we will do with the decrement array. We will check whether it is present in the set or not. If it is not present, we will simply push it in the queue and in the string. Here basically we are pushing it in the string, marking it as visited. Okay, the same thing we do by using visiting array in BFS. So now I think it will work fine. there is some sort of, okay, I forget. Okay, so here this will be q dot size. I have done a mistake here. This will be q dot size here. Now I think it will work fine. Okay, now let's submit it. So now it is accepted. Here the time complexity is basically order of 10 to the power 4. Okay, time complexity is basically order of 10 to the power 4 because here the maximum number of time the BFS can run is basically 10 to the power 4. Okay, that is basically the number from 000 to quadruple 9, right? And the space complexity is also order of 10 to the power 4, as the length of that particular unordered string can be max from 000 to 999, as we are storing all the strings, the strings of the dead ends, the strings of the dead ends, and also we are using this in the BFS traversal by storing the visiting string. Okay, so its max length can be 10 to the power 4. So here the space complexity is also order of 10 to the power 4. So if you understand the solution properly, then please like and subscribe to my channel.